In this lecture, we're going to look at the single-minute exchange of die approach to reducing setup times in order to increase capacity and allow flexibility in our process. The learning objectives here are to calculate the effect of reduced setup times on capacity, to list and explain the 6 stages in the single-minute exchange of die, or SMED, approach from Shiego Shingo, to explain the difference between internal and external setups and to give examples from industry, and to understand and discuss the impact of reducing setup times in lean production. Now, as we learned, setups are often necessary to add flexibility to our production because different products may require setups between the different product types. And to reduce the impact that setup time has on capacity, production is often done in batches. And we looked at this example of a machining tool for making propellers. And this one single tool made both the base and the propeller head. And there was a 1-minute setup between parts, or in other words, a 2-minute setup time needed per flow unit. Per propeller. You needed 2 minutes of setup time. Now, the equation we use to calculate the capacity with setups is the total number of flow units produced divided by the total time. And the total time was the total setup time needed to produce those flow units plus the production time for those flow units. We also wrote that in terms of batch size. In other words, for one particular batch size, you would need to have a time to produce that batch size plus the setup time. And in this case, we had it equal to 2 minutes. And here we saw the example of batch size equal 1, batch size equal 2 is batch size equals 3. And we calculated the capacity for each of those as we showed here. Batch size equal 1 was 7.5 units per hour, for 2, 8.57, and 3 was 9.00 units per hour. So as we increased the batch size, we increased our capacity, but we saw that that was at the expense of having more inventory in our process. So what can we do? And here we see a small setup time. Let's reduce our setup time to 30 seconds plus 30 seconds equal 1 minute. So in other words, the machining tool needs 30 seconds to set up between making its different parts, the base and the propeller head. So instead of 2 minutes, we only need 1 minute. So how does this work? We need only 1 minute. Here we need only 1 minute. Here we need only 1 minute. For batch size equal 1, this gives us 1 over 1 plus 6, or 1 over 7. Which is then going to be equal to 0.143 units per minute, which if you multiply that by 60, gives us equal to 8.6 units per hour. If we have a setup time reduced then from 2 minutes to 1 minute. Same thing for the batch size of 2. In this case, we get a reduced an increased capacity of 0.154 units per minute, which is equal then to 9.2 units per hour. And finally, with 3, we would end up then with 0.158 units per minute, giving us 9.5 units per hour. So, what you see is reducing the setup time, bringing it down. The setup time then becomes a smaller portion of your total time, and your capacity goes up. And actually, we're getting here 9.5 is moving close to our ideal. With 0 setup time is 1 over 6, or 10 units per hour. Can't avoid it, but we're moving closer if we reduce our setup time. But how can we do this? The classic example is from the racing car pit stop. Now, back in the days, what do you notice here? Well, first of all, the car is going for its pit stop. It's not positioned very well, and in that time, the parts were not designed for fast changeovers. The tools weren't necessarily at hand, the team not very well trained, and no real standardized processes. But Time was not tracked as time lost during the pit stops, during the changeover, so it didn't make a difference. What do we have today? Well, we have instead a streamlined, extremely efficient process. The car is quickly positioned in an ideal spot with the tools readily available. You have a coordinated team for the change, which is very well trained, and they practice very often. And you have time tracked carefully with crews graded for their speed and accuracy. Now here, of course, you're also looking at many people involved in the changeover. A very sophisticated process with a sophisticated team may not be entirely possible for your production. However, this is the example of how minimizing setup time for the next stretch of the race can be, or is, the difference between winning and losing. So let's see what we learned from this example in terms of the SMED, or single minute exchange of die approach.